Okay, let's dive into this. Welcome, everyone. I am absolutely thrilled to be your strategist for today's explainer because we are tackling one of the most brilliant, powerful tools in all of mathematics. Seriously, whether you're trying to calculate the vast, mind-bending, infinite distances of the universe, or you're zooming all the way in to measure the microscopic dimensions of a single living cell, standard form is your mathematical skeleton key. It literally unlocks the ability to handle the extremes of scale without completely losing your mind in a sea of zeros. Now, if you're preparing for your Cambridge IGCSE 0580 mathematics exams, let me be very clear. Mastering standard form isn't just a helpful little trick. It is an absolute requirement for top marks. It's the foundation of how we communicate huge ideas in science and math. So get comfortable, get rid of any distractions, focus in, and let's decode exactly how we manage these extremes. We've got a lot of ground to cover.
Here is our strategic roadmap for today. First, we're going to unpack the giant number problem. Then we'll establish the golden rule. After that, we dive into calculating with standard form, followed by a crucial segment on using your calculator. And finally, we'll shrink things down to explore the microscopic world. All right, moving right along to section 1, the giant number problem. This is really about understanding exactly why standard form even exists in the first place. To truly appreciate why standard form is such a game changer, we kind of have to take a quick trip back through the history of human discovery. Picture this. It is the year 1610. The brilliant astronomer Galileo, right around the same time as a German astronomer named Marius, points his telescope at the night sky and independently discovers the 4 largest moons orbiting Jupiter: Io, Europa, Ganymede, and Callisto. Now, at this point in history, the widely accepted, unquestionable belief was that the sun and everything else revolved around the Earth. But Galileo's discoveries completely shattered that. He proved that the Earth actually revolved around the sun. This was so incredibly revolutionary and honestly so controversial that the church literally declared him a heretic and imprisoned him. Wildly enough, it took the church another 350 years to officially pardon him in 1992. But here's the thing. Galileo's cosmic revelation opened up a massive practical problem for mathematicians and scientists going forward. The universe is unimaginably, incomprehensibly huge. Think about what happens when we actually try to quantify that huge universe. Check out this number. This is the estimated mass of the planet Jupiter measured in kilograms. That is a 1, a 9, and then 27 zeros. Just take a second to let that sink in. 27 zeros? Now imagine being an astrophysicist trying to write out a complex equation using this quantity. Imagine having to multiply it or divide it by the mass of the sun. It's a total nightmare. One slipped pen stroke, just one single missed zero, and your entire calculation is ruined. It's completely unmanageable. Standard form, which you might also hear called scientific notation, was invented to solve this exact problem. It's a system that allows us to compress these massive, sprawling numbers into something incredibly neat, structured, and manageable, using powers of 10. Before we continue, subscribe to our YouTube channel Ace the Exams at acexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Let's transition into section 2, the golden rule. This is the mathematical blueprint you need to memorize. If you take away just one single concept from this entire explainer, please let it be this exact mathematical blueprint. Think of it like a jazz musician learning music theory. You absolutely have to know the rules perfectly before you can improvise and fly through your exam. For any number to truly be in standard form, it must precisely follow this structure: a times 10 to the power of n. Here is the critical part, the ultimate golden rule. N must be an integer, meaning a whole number, positive or negative, and a, absolutely non-negotiably, must be a number between 1 and 10. Let me be super specific here. It can be equal to 1, but it must be strictly less than 10. It cannot be 10, it cannot be 0.5, it cannot be 42. Remembering this simple, strict boundary prevents literally the most common errors I see students make on Cambridge exam papers year after year. Let's break this down with a real example. Let's take the number 3100 to see this rule in action. Mathematically speaking, 31 times 10 squared is equal to 3100. That is a true statement. So is 0.31 times 10 to the power of 4. But if you write either of those on your exam, you are losing the mark. Why? Because neither of these are in standard form. 31 is way bigger than 10, and 0.31 is smaller than 1. They completely break the golden rule. The only correct way to write this in standard form is 3.1 times 10 to the power of 3. That a value, the 3.1, fits perfectly into our golden 1 to 10 range. You have to keep that rule locked in your mind at all times. All right, section 3, calculating with standard form. Let's start applying the rule.
Now that we know the rigid structure, how do we actually do math with these compressed numbers? Let's walk through an addition problem step by step. Say we want to add 3.8 times 10 to the power of 6 and 8.7 times 10 to the power of 4. First instinct, just add 3.8 and 8.7, right? Wrong. You absolutely cannot add those straight away because they are scaled to completely different magnitudes. One number is in the millions, the other is in the tens of thousands. Step 2 is the secret strategy. You have to change the indices so they match. It's kind of like finding a common denominator for fractions. So we rewrite 3.8 times 10 to the 6th as 380 times 10 to the 4th. Boom. Now that the powers of 10 match, step 3 is easy. We simply add the front numbers together. 380 plus 8.7 gives us 388.7 times 10 to the 4th. But wait, hold on, look closely at 388.7. It breaks our golden rule, doesn't it? It's way bigger than 10. So step 4 is our final, absolutely essential cleanup phase. We convert it back into proper standard form by moving the decimal 2 places to the left, which increases our index by 2, giving us our final perfect answer, 3.887 times 10 to the power of 6.
Multiplication is a slightly different process, but that same vigilance regarding the golden rule is required. When you're multiplying numbers in standard form, you multiply the front numbers together, and then you use your laws of indices to add the powers of 10. Let's do it. 2.4 times 5 gives us exactly 12, and 10 to the 4th multiplied by 10 to the 7th, we add those powers, 4 plus 7, which gives us 10 to the 11th. So we combine them to get 12 times 10 to the 11th. Is that our final exam answer? No way. Because 12 breaks the golden rule, it is greater than 10. We have to do one final conversion, shifting the decimal just one spot to the left to turn that 12 into a 1.2. And because we did that, it naturally bumps our index up by 1. The true final standard form is 1.2 times 10 to the power of 12. The key takeaway here, always do a final check of your answer against the golden rule before moving to the next question.
Stop scrolling, subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump into section 4, using your calculator and navigating the exam interface. For IGCSE course students especially, calculators are fully allowed and frankly heavily relied upon for these exact calculations. But here is the hard truth. A calculator is only as smart as the person typing on it. You have to know your specific instrument. Different calculator brands have completely different buttons for inputting standard form. On a modern Casio calculator, you are looking for that dedicated button right at the bottom center that says times 10 to the power of X. It is a lifesaver. It does all the heavy formatting lifting for you. On a Texas Instruments calculator, however, you're usually looking for a button labeled EE. Walking into the exam hall and knowing exactly where your physical tools are is half the battle. Don't let a poorly typed input steal your marks. Now, knowing how to type it in is one thing, but interpreting what the calculator screen spits back at you is just as crucial. If you enter a massive calculation that results in a 1 followed by 15 zeros, your calculator will automatically display it in standard form to save screen space. A Casio will usually display it really nicely, exactly as you'd write it, 1 times 10 to the power of 15. It's great. But a Texas Instruments calculator, or even some older models, might show it as 1E15. Please listen to me very carefully here, as this is a massive exam strategy tip. Never, ever write 1E15 on your actual written exam paper. The examiner will not accept it. That E is just calculator shorthand for times 10 to the power of. You must always translate that digital display back into proper mathematical notation, 1 times 10 to the power of 15. Let's move into our final concept. Section 5, the microscopic world and negative indices. Up until now, we have been dealing entirely with massive cosmic numbers and positive indices. But what happens when we go the other way? What happens when we look down a microscope at a virus or the width of a human hair? This is exactly where negative indices come into play. We use a negative index when writing a number that is incredibly small, specifically any decimal value between 0 and 1. Now, the beautiful thing here is that the exact same golden rule applies. Our front number, our A value, still absolutely has to be between 1 and 10. So let's say we need to convert 0.0032 into standard form. We grab that decimal point and we shift it to the right, jumping over the zeros, until we land on a number between 1 and 10. In this case, we land on 3.2.
Because we moved the decimal 3 places to the right, essentially taking a tiny number and making it look bigger, our index has to balance that out by becoming a -3. So the final answer is 3.2 times 10 to the power of -3.
Notice how beautifully standard form lets us organize scale, from the absolute largest values to the unbelievably small. Here, we've organized various values entirely by magnitude. At the top, 680,000 compresses nicely into 6.8 times 10 to the fifth. Then, look all the way down at the bottom. A tiny, tiny fraction like 0.00000000557 compresses effortlessly into 5.57 times 10 to the -9. Here's a pro tip. When you are asked to order numbers by magnitude on an exam, the exponent, the index, is your true driver of size. Always look there first. A +5 is obviously much bigger than a +3. And interestingly, a -4 is bigger than a -7. Why? Because -7 is further away from 0 on the number line, meaning it represents a much, much smaller decimal. Standard form allows you to instantly scan, sort, and compare the true scale of numbers without ever getting lost in that sea of zeros.
I want to leave you with a real-world, high-level challenge drawn straight from the Cambridge syllabus to test everything we've just learned. We know that light from the sun travels at a blistering speed of 3 times 10 to the power of 8 meters per second, and it takes approximately 8 minutes for that light to travel through the vacuum of space and reach our eyes here on Earth. Based on the rules we've covered today, can you calculate the exact distance from the sun to the Earth and present your final answer in perfect standard form? Remember your strategy. You'll need to convert those 8 minutes into seconds first to match the units, and then carefully apply your standard form multiplication rules, checking your final answer against the golden rule. Grab a pen, test your new knowledge right now, and see if you can unlock the scale of the solar system yourself. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.